All right, we've already talked about atoms and how to figure out how many protons, neutrons, and electrons are present within the atom. We've also talked about isotopes. Those are when we have the same element, like carbon 12 and carbon 14, but they have different masses because they have a different number of neutrons. Another big vocabulary piece that we have are ions. Ions are when a neutral atom either gains or loses an electron or electrons. So remember, electrons are on the outside of the atom. So they are the particle that is involved in reaction. So electrons can be gained and lost. And when that happens, then you no longer have an equal number of positive and negative charges. So you end up with an overall charge. So today we're just going to be talking about individual electrons being gained or lost, but in real life, when we have reactions, it's a transfer of electrons. So one substance would be gaining, something else would be losing. Once you change the number of electrons, that will end up with a charge. So you're going to see something like aluminum with a +3 charge. Now you might see it written +3 or 3+. You don't really have to worry about what the difference is between those two notations. As a reminder, protons are never gained or lost because if we change the number of protons, then that would change the number, or that would change what the atom is, because that would change the atomic number. So if you have aluminum, you have to have 13 protons or else it wouldn't be aluminum. So we're not going to be gaining or losing protons, it would be electrons. Another vocabulary word is a cation. A cation is a positive ion. So when I write this out, the T kind of looks like a plus sign, so that's how I can remember that cation refers to a positive ion. And positive ions occur when we lose electrons. And we'll look at an example in a minute about that. And elements on the left-hand side of the table, those would be our metals. When they react, they tend to lose electrons to form cations or positive ions. So let's look at an example. Let's take aluminum. Let's say we have aluminum with its most common mass, so a mass of 27. So regular aluminum with a mass of 27, we find that on the periodic table. Its atomic number is 13, so it would have 13 protons. If the mass is 27, then we would have 14 neutrons, so that they add up to give us 27. If there's no charge in the upper right-hand corner, then it's a neutral atom, and we would also have 13 electrons, so that we have 13 positives, 13 negatives, overall no charge. Now let's look at the aluminum 27, so we'll keep the same mass, +3 ion. So your protons still have to be 13, or else it wouldn't be aluminum. If the mass is still 27, then we still have 14 neutrons. But now the electrons would be 10. So when we have a positive ion, we've lost electrons because we would have 13 positive protons, so a +13 charge from the nucleus, and then 10 negative electrons. So that's what gives us the overall charge of +3. So when you have a positive ion, you have lost that number of electrons. Our negative ions are called anions. So those are our negative ions, and they result from the gain of electrons. Because since electrons are negative, if you gain electrons, then you'll have an abundance of negative charge. So elements on the right-hand side, those would be our nonmetals, right-hand side of the periodic table, tend to gain electrons to form anions. And again, we'll take a look at an example here. So let's say we have phosphorus. Phosphorus's most common mass is 31 and no charge. So this first one's an atom. Protons would be 15 because phosphorus's atomic number is 15. If the mass is 31, then we would have 16 neutrons and no charge. So we would have 15 electrons, that we have an equal amount of positive and negative charges. If we have phosphorus, still with a mass of 31, but now with a charge of -3, we still have 15 protons, because if it's phosphorus, its atomic number has to be 15. The mass did not change because adding or subtracting electrons doesn't impact the mass, since electrons are essentially massless. So the neutrons would be 16, so that 15 plus 16 equals the 31. The electrons are what changes when we have a charge. Since we have a negative charge, we have extra electrons, so now we would have 18 electrons. So we would have 3 more than what would be present in the atom. You can always check your charge off to the side. You have 15 positive protons in the nucleus, so the nucleus has a charge of plus 15. You have 18 negative electrons outside the nucleus, so that gives us an overall charge of -3. So when we make an ion, we gain or lose electrons. If we lose electrons, that forms a positive ion. If we gain electrons, that forms a negative ion. All right, lastly, we just have a couple of examples to work through. So our first one is chlorine, and chlorine with a mass of 35, and it's the atom, which means that we don't have a charge, so it's neutral, so you'll have an equal number of protons and electrons. So chlorine's atomic number is 17. If it has no charge, it must also have 17 electrons. Since the mass is 35, the neutrons must be 18 because protons plus neutrons equals the mass. Now in number 2, the only thing that has changed is now I have a -1 charge, so it's an ion. The proton still has to be 17 because the atomic number can't change, or else it would no longer be chlorine. The mass didn't change, so the neutrons are still 18. But I have a -1 charge, which means I have extra electrons. So now I have 18 electrons. I have extra electrons, so the overall charge is negative. Next one, we have potassium. So we have to find potassium on the periodic table. It's in group 1, and potassium's atomic number is 19. So therefore, we have 19 protons. Since it's an atom, no charge, so we also have 19 electrons. So we have an equal number of positive and negative particles. If the mass is 39, then I have 20 neutrons. And in number 4, the only thing that has changed is now I'm a +1 charge. Protons can't change, or else it would no longer be potassium. The mass is still 39, so I still have 20 neutrons. +1 means I lost an electron because now I have less electrons, so less negatives than I have positives. So I would have 18 electrons. And our last one is calcium. Calcium is right next to potassium. Its atomic number is 20. So if I have 20 protons, also have 20 electrons if it is a neutral atom. And its mass is 40, so I would have 20 neutrons. And then in my final example, the only thing that has changed is now it's a +2 charge. So still atomic number of 20. The mass is still 40, so I still have 20 neutrons. But now I have 2 less electrons, so I have less negatives. So that gives me an overall positive charge. So since it was +2, then my electrons would be 18.